Hey everybody, welcome back to the PC Perspective Mailbag, episode 22. Sorry you don't get Josh back this time. You're stuck with me. It is Star Wars Day. The Last Jedi is coming out tonight, and instead I will be visiting Santa Claus at the Polar Express. It's a long story. Watch our podcast if you don't know what the hell I'm talking about. Let's jump into it. Danny Fleming wants to know, when will you be able to review a laptop with a Ryzen APU? The answer is presently. We actually have the HP NV360, X360 in the office now being tested that has the Ryzen Mobile APU in it. And we actually also have the previous generation of an HP machine using the last gen APU from AMD. That'll be an interesting comparison. And then obviously we have a whole host of Intel hardware here to compare it to. So it'll be really interesting to see a couple of things. One, I'm really interested in battery life. That's obviously very important for mobile machines, corresponding to power consumption and all that. And then obviously performance is interesting, right? So the CPU side, in general, I think what people assumed would be the case is that the CPU would be lower performance than the Intel hardware, and the GPU would be higher performance than the Intel hardware. And early kind of results we've seen actually indicate that the CPU might be very performant as well, giving indications that maybe the AMD has tweaked clocks enough to get better performance. But is that at the sacrifice of power consumption and battery life? I think we'll find out fairly soon and fairly easily once we get a hold of, or not once we get a hold of it, once we actually integrate some of our testing into these devices. It's the first machine, as far as I know, it's the only machine right now that's shipping with Ryzen Mobile APUs. I expect when we visit AMD at CES next month that we will get hands-on time or some preview time with a bunch of other machines that are using Ryzen APUs. And then I think the other interesting part is how much does AMD, or how much does Intel talk about that new processor that they announced that has AMD discrete graphics on the package, if you will, and how they push and market that, right? It seems like that's going to be a much higher wattage part, more for maybe mobile workstations and less for just mobility stuff. But I'm really curious to see how that pans out as well. So the answer to your question, Danny, is very soon. We'll have reviews up very soon. Next question, Eric Elzinger wants to know, in a custom water cooling loop, does the order of the components matter? For instance, should my CPU block be before the GPU block in the loop? The order of the components does matter in that you're basically passing in a standard kind of custom-made water cooling loop. You are passing the heat around in a loop until you get to the radiator, which then cools the liquid, the water, whatever you want to call it, down before going through the pump and back out to the rest of the components. So it can matter in terms of where do you want the coldest water to get first. And talking to some of the guys here, it probably makes sense to go to your CPU cooler, go through your CPU first, right? So maybe you're trying to overclock that the most. Or in general, we like to think that processors should run at a lower temperature, maybe in the 60 to 70 C range, as opposed to your GPUs running into a, 80, 85 C range. That would mean that you would want to pass the cooler water into the CPU block first, and then maybe pass that off to the GPU second, then into any other components you have, to your radiator, and into your pump that way around. So it does kind of matter. I think at some point things may level off, but in general, the water will always be coolest after it comes through your radiator and then through the pump out into whatever device you are most concerned about having cooled most effectively, which I think would probably be your CPU. Unless if you're doing GPU workload only, you're not overclocking your processor, you're not really worried about that, then you might pass it through your GPU water block first and then into the CPU. So options there, but it does matter what order you put that system into. Tyler Humphreys wants to know, will NVIDIA support variable refresh rate as part of the HDMI 2.1 spec? Will they be required to in order to have HDMI 2.1 certification? This is actually a really interesting question. So it was just last week HDMI 2.1 spec came out, and it had some provisions in there for, higher resolution, higher data rate, HDR, all that stuff, all really important, really neat stuff. But it did mention variable refresh. And people who haven't been keeping track, the G-Sync versus FreeSync debate is interesting because G-Sync was created before there was any attempt at any kind of standardization to that technology. And FreeSync exists as adaptive sync, which is an optional part of the DisplayPort 1.2a standard. Yeah. With DisplayPort 1.3 and 1.4, we have not seen any requirements for variable refresh. For HDMI 2.1, it appears, based on my initial reading of what the spec is and what the highlights are, that variable refresh support will be required. Now, if that's the case, I'll be really curious to see what NVIDIA's reaction is going to be. They could choose to not support HDMI 2.1, but support all of the other features and not actually officially support HDMI 2.1, but that would seem to me to be a very poor decision on their part. The pretty bad marketing move in my estimation. But they could also support HDMI 2.1 variable refresh at the minimum most level that they could, which I think most people would still be pretty okay with when it comes right down to it. That being said, HDMI 2.1, having just been announced, is probably a full year from integration and implementation, right, into products and the displays, into graphics cards and systems and other silicon. So there's still some time for us to figure out what NVIDIA is going to do. That might be something we hit them with up at CES and say, hey, these new specs are coming out. What are your plans for it? I would like to see maybe NVIDIA open their products up to adaptive sync and HDMI 2.1 and leave G-Sync. I don't want to say abandon it, but if you have more advanced features that are on top of things like just standard variable refresh at this point, then you go down that path for branding something like G-Sync 2 or what have you. But we'll see. Next question from D. Jotter. What resolution do you think the next generation VR headsets will support? I have no idea, right? So what's interesting is the next generation of VR headsets after Vive and after Oculus Rift really feel like they're mobile devices, right? These are mobile freestanding headsets not connected to a gaming PC, which puts us into a very different classification of performance. In theory, what you want to get is just to the highest resolution possible in these screens so that you remove screen door effects, you remove any kind of visualization issues. But if you try to just increase the resolution haphazardly without taking into account the amount of compute power you're putting behind it, it could lead to frame rate dips and just like maybe lower anti-aliasing quality, lower filtering quality, just less capability in the system as a whole. That would be, I think, worse than leaving resolutions alone at that point. So I don't think we've seen really any rumors about future connected to a PC-based VR systems. CES is coming up. I think we just scheduled a meeting with Vive to talk about some stuff. I don't know if that's going to be something that comes up, but both Vive and Rift have been talking about, Qualcomm mobile chip powered VR headsets that do run at fairly good resolutions. But 25 by 14, 4K, that seems like where we're going to go. The more pixels per eye, the better. But I don't really have a good estimate on where I think the next generation of VR headsets will land, or even what the definition of the next generation of VR headsets really is. So again, something else for us to find out at CES. The Lion's Kiln wants to know, I have an X99 motherboard with a 6800K and a GTX 970. I recently found that used 6950X processors are going for $800 to $900 on eBay. Is it worth it to upgrade my existing system to the 6950X, or should I build a new system on a more recent architecture? So the 6950X launched at $1,700 but was overpriced when it launched. That was kind of like the holy crap, Intel's losing touch with reality product launch, right? Where all the previous generations had launched at $99 or $1,100, and this time, excuse me, they launched a 10-core part that went up to $1,700. So $800 to $900 might feel like a really amazing deal, and you are getting a 10-core processor with 20 threads, and it's got a reasonable base clock and a reasonable max clock up to 3.5 gigahertz. But honestly, for that kind of money, I would save the $900 and look at building something on an X299 platform, right? So if you look up what the, let's see, 70, what would it be? 7900X, that's an 8-core part from Intel. I'm sorry, no, that's a 10-core 20 thread that's going to have a much higher max frequency, almost a gigahertz faster. And it's about a $900 processor. So for the same amount, you could get 10 cores, 20 threads, but you are going to have to buy a new motherboard, and whatever else associated stuff needs to be upgraded along with you. So right, I would kind of, if I were you, I would not invest in a 6950X, even though it seems like a good deal, $800 to $900, knowing you could get, for $100 more, $200 more, you could get the more modern architecture, better platform, higher clock speeds, better single-threaded performance, better multi-threaded performance across the board if you go with the 7900X, if that's the kind of platform you're into. So that'd be my recommendation there. Richard wants to know, or actually says, I like the idea of Windows on ARM and features like connected standby, but historically, bold power efficiency claims with x86 systems haven't panned out. Do you think that the Windows on ARM systems will truly let us, for example, close our laptops at night and have the same level of charge remaining when we wake the system in the morning? Yeah, actually, I do think that, right? So I have been able to use Windows on ARM, Windows on Snapdragon devices for a while now, and I've been pretty impressed with its actual capability to maintain charge throughout standby. There are pros and cons to this platform regardless. The pros in the connectivity option and obviously in the battery life. The cons being in the performance side. It's going to be less performant than a $700 to $800 Intel laptop with a dual core or a quad core processor. That's just how it's going to be. This is more Core M3 level performance. It's perfectly fine for doing basic web browsing and productivity and all that type of stuff. But if you're doing anything heavier than that, it's probably going to be difficult to justify not buying a higher end, higher performance Intel system for that. But if you care about battery life, and I do a lot, and you care about connectivity, which I think I have come to really depend on here, the Windows on ARM and Windows on Snapdragon system makes a lot of sense. I have used the devices and had them in my laptop for 3 to 4 days, not opening them up at all, take it out and still have 80-something% battery left. And it is still the instant on. It doesn't have to wake up from a hibernate state or anything like that. If I leave my, ThinkPad X1 in my laptop or my backpack for 3 days, when I turn it on, it still has some battery, but it is gone into hibernate state. Whereas the Windows Snapdragon machine did not have to do that. So no, I do think that there is a legitimate battery life difference and platform architectural difference that allows Snapdragon hardware to run lower power sleep states while still being connected compared to what Intel can do. And I think that's probably why we don't have a true definition of what an always connected device is from Microsoft yet, is because Intel, whatever Microsoft wants to define it as, Intel can't meet it and AMD can't meet it, so they don't want to create a standard for marketing and branding purposes that their biggest partner, Intel, can actually meet yet. They will eventually. They'll get there. Intel will get there, but they cannot yet. So that's probably the most interesting part of those Windows on ARM machines. Street Guru wants to know, will we ever see something like the reverse of hyperthreading, i.e. combining 2 physical cores into 1 virtual thread for improved IPC? You want to SLI your cores on your processor. It's an interesting idea. As I read the question earlier, just trying to think through, like, how would something like that work? I just think the problem with that idea is that an out of order a scalar, architecture like this is incredibly complex compared to the simplicity of something like a GPU processing pipeline, right? Not to discount the complexity of a GPU in its entirety, but something like combining, multiple compute units on a GPU is a much more simple task because the workflow that they've been designed for is highly parallelizable. Whereas in general, the stuff that is being used like on a single thread on an x86 part will tend to have significant branching, cache mispredictions, cache misses, I guess I should say, and all of that stuff trying to balance it between two physical cores that have different cache structures and all that stuff, I think would be really difficult. I think at that point, if you're trying to go down that task from a software mindset, you really need to figure out how do you disconnect that thread into multiple threads to then enable higher performance on these multi-core, multi-threaded processors and systems. So it's an interesting idea, though, reverse hyperthreading. I think we just call that running cores. Kyle Bachman wants to know, could you explain what deep learning is? I hear this term a lot these days. It's like art. You'll know it when you see it. I don't know. That's not true. Deep learning is essentially, and I'm not like especially studied up on this necessarily, but it's a machine learning method that's like generally considered like part of artificial intelligence, learning data, and the key of what deep learning kind of indicates is it's also called hierarchical learning, is that it uses multiple layers that stack on top of each other in order to come to some conclusion, right? So each successive layer uses the output and results and data from the previous layer as input, right? And so that is the part where the idea is you give it 10,000 images, it looks at them and tries to figure out which one is the dog, goes to the next level, it's using the data from the last one and down the stack. It's the truth is it's a very kind of ambiguous term. If you look stuff up on Wikipedia, right, it's going to talk about learn multiple levels of representations that correspond to different levels of abstraction, right? You can call it deep structured learning. It's part of a broader family of machine learning methods based on learning data representations as opposed to task-specific algorithms, right? And there's all kinds of diagrams that show you this. You can talk about supervised learning, clustering, structured predictions. It's kind of a very broad term that I guess also has some, according to this, educational psychology background in it, deep versus shallow learning capabilities. Deep learning architectures such as deep neural networks, there's some other terminology and keywords you're probably seeing recently, deep belief networks, and recurrent neural networks have been applied to fields including computer vision, speech recognition, natural language processing, audio recognition, social network filtering, machine translation, bioinformatics, and drug design. So it's probably not a great answer to the question of what exactly deep learning is, other than it is a multi-layered state and capability for computers that use algorithms. They use previous layers' results as the input to future iterations of it. Josh French, wants to know, what would be the best SSD to use as a cache drive in a 24/7 storage server? I asked Alan this question. He said, without knowing the server structure and what software you're using and all that stuff, in general, anything that writes to SLC is going to be best. So an Evo drive, right, is going to be good for this because even though it's got a small bit of SLC on there, if you're writing to it, it will be able to write to the system as fast as possible, and then the SLC will distribute it to the whatever TLC is on the drive or what have you, and then off to the hard drives of the storage server itself. How big of a drive you need depends on how much you're going to write and how quickly you're going to write. And keep in mind, you're still over a network, so if you're running over gigabit network, you're talking about maximum write speeds of 100 megabytes per second. How big of a burst are you going to have for that? And how worried are you about the hard drives in that system being able to keep up with the write capability? For reads, you need to have a bigger cache drive. The bigger the cache drive, the more potential advantage you'll have for actual reads from that storage server, because it has the more opportunity to actually cache the data that you are going to be needing. In general, I think the idea of a read cache on a storage server makes not as much sense, because in my mind, if you're using something that frequently, it should probably be on a local system, but everybody's going to have a different system design, right? Alan did mention the idea of Optane, which is going to have, tremendous performance, but the latency advantages you get with Optane are not really advantageous over a network. But if you need something like 32 or 60 gigs or what have you, that might be an option for that as well. So anything that writes to SLC is going to be the best. So think of anything like an Evo drive, and then pick your capacity based on your budget and how much you think you'll actually be using it, I guess. So last question comes from Sam Biscuits. Ryan, your daughter is super cute. Thank you. Does she play any PC games? She doesn't play any PC games. The only PC game she plays is mess up daddy's work by sitting on his lap while he's using his laptop and touching all the keys and trackpad and stuff, even though I've asked repeatedly for her to not while we're doing something on the computer. She hasn't really played a whole lot of video games yet. So she's 2.5. She knows who Mario is. She saw me play Super Mario World on the SNES Classic, I believe once, for about 20 minutes. And then can now immediately recognize him. She has picked up the NVIDIA Shield handheld device and knows how to put her hands on it and hits the buttons and stuff, but she doesn't really know what's going on yet. But she does play iPad-based games, and she knows how to navigate those systems very well, which is impressive to watch. So, and she knows, I will say this, to her credit, she knows what a keyboard is and how you're supposed to use it. She knows what a mouse is and how you're supposed to use it. I don't think she's actually done any tasks using a mouse and keyboard yet, but when she comes to my office, she knows how to sit at the desk and where her hands go on the keyboard and how to use the mouse and move things around that way. So we're close. We're getting there. We're getting there close. Thank you guys again for hanging out. Make sure you leave us your questions. We need more of them in the comments to this video or in the comments on PCPer.com where this video is posted. Leave us your questions. Anything about the holidays coming up, CES predictions, all that stuff is fair game. And we will have another episode ready for you guys next week. See you at PCPer.com. Thanks, everyone.